analyze those batches. But now the number of data is being basically streamed. So in the real time, you are getting huge amounts of data. So we are getting huge amounts of data, but that also poses a challenge how to, in the real time, analyze those amounts of data. And last but not least, and certainly one that brings probably the most problems actually in this, would be the variety of that data. Just think about it. A few years ago, we didn't even consider and use Facebook or Twitter like we do right now. And that's just one single aspect. That's what social media, which is generating a tremendous amount of more or less useless content. But then again, there is a number of sensory networks being used in agriculture, being used in weather prediction, being used in so-called smart cities and smart grids. And what's common with that is the fact that we are generating an awful lot amount of the data. But it's not, again, as I said, for the volume, we don't have a single solution that will solve that problem. Same thing is here. I would think that the main issue here would be the fact that the majority of that data is actually unstructured. If we could have all the data in some sort of a, I don't know, JSON-like format, doesn't have to be necessarily the same, but just by writing different adapters and writing a good analytics software, we will get far along. But the fact is, the challenge that remains here is that you don't have a standardized data delivery protocol, data delivery format, or you don't even have an idea of what to do next. And that all is basically putting so much more pressure on just trying to understand what the big data is and just to get the actual insight. So now, having this all behind ourselves, there's several stats, as I would like to call them. As I mentioned earlier, I see people nodding heads. I think that some of you might have seen these infographics, and the slide after that is one from the IBM. There's a number of them. What is really interesting, you have to be careful when you're looking for them, because the ones from the 2011 and 12 and 13 are drastically changing. So you can see on the ones which are all just 1 year, they're saying that there are around 36 to 38 million tweets per day. Then it was 230 million, now we're talking about 500 million a day. And it's all happening just within a course of literally 1 year. So much about all those three characteristics I just described. Facebook generates daily about 30 billion pieces of content. And as I said, some of that content is probably completely useless. Some of that actually can provide us with insights. And for the fact that from other customers we know that the large brands are very much interested in grasping the insight from the big data. People are talking about their brands. So if you, for example, if you are owner of Starbucks, which I'm not aware that some of you are, but still, if you have a Starbucks, you would like to know, who is talking about your brand, in what kind of sentiment, is it positive, is it negative, and how that person is actually, is it influential? Can it be a decision maker or someone who can foster the communication around your brand? And if it can, you want to recognize that person, target your marketing towards that person, and be sure that your messaging is being delivered. That's just a single element of what big data can do for us. The other one is IBM just recently announced, I think it was literally last week, so it's a very, very, very fresh news. They announced their software and platform, which will help people to understand, prevent, and basically forecast the outbreaks of malaria. Also largely based on the big data and also based on crowdsourcing, so that people which are in Africa and on the areas which are very vulnerable to malaria, they can report those findings, and then their clusters and software and basically all the tools they build can gain them valuable and actionable insights. As you move along through this presentation, I will try to move you up. When I'm mentioning data, most of the people actually are thinking in sort of Excel spreadsheets or some sort of tables. Not many people think about the data necessarily in the form of visualizations, which is a shame, but completely understood from this perspective. What I'm going to do later on is just to give you a brief, as I said earlier, just to give you a brief understanding of, just by transforming the view of the data, what we can get from it. And definitely the stat that completely is amazing is that, as I mentioned earlier, 90% of the data currently on the internet has been generated in just past 2 years. I think they say that on YouTube every second there are 26 hours of videos being uploaded, and just yesterday people have watched 2 billion videos on YouTube. We might ask ourselves, and completely with a good reason, why would we even care about that? You know, someone is watching the video. Then again, you can put yourself in the position of a brand, and you would like to know what's the conversation going on about. Are you part of it? Are you taking part of it? Because people will talk about you, and neither, you know, they don't really care do you involved in or not. So, but you might be missing a lot. But the main challenge still remains how to get the big insight from the big data. How to move from the tabular, from JSON, from XML, from any sort of the data to something that you can actually work on and accomplish any goal that you want. So, why big insight? As I said, from the big data we don't get a lot of information, but from the big insight we might get more valuable information. Have you seen the citydashboard.org project? Not familiar with it? Okay, so this is the city dashboard for London. They have a number of sensors all across the city measuring some usual stuff that you would expect, like the humidity, temperature, I don't know, the amounts of gases, so is the air of a good quality or not. But they also have digitalized, and they have a number of sensors for rent-a-bike posts that you have in London. So you can see through all our available bikes in the past 24 hours. You can easily see when there is a rush hour, how the number of bikes drops, and then again, when people are coming back from work and they're also taking those bikes. So the number of valuable or less valuable information depends on, you know, basically your sources. But the main thing would be, what kind of them do we need here? Do you think that something like this is useful at all? And to what degree? I mean, it could be interesting if you want to get a, you know, quick snapshot, come and take a look at the London and, you know, understand what's the weather like right there, and, you know, understand stuff like that. But we should not be doing big data, we should not be doing visualizations and all that stuff just for the sake of it. Which, unfortunately, is so often in our industry, not just regarding the big data, but pretty much anything. So people are inventing problems just so they can solve them. But that's completely another story. Moving on. So how the typical process looks. So first of all, you do the data acquiring. So how do you do it? You can do it either through sensory networks, as I said. You can do it by listening, Facebook, Twitter, or any social chatter that's going on. So you have to get to the data somehow. People say that sensory networks are probably going to be the #1 source of the big data, of the data itself that we are going to get in the future. Then it's obviously parsing. And as I said earlier, we still don't have this single common format, and we probably will never have. But we need to build either different adapters or any sorts of mechanisms so we can get that data, no matter how unstructured or structured it can be, into our system, so that can be provided with so that we can deliver and get the insights from it. Obviously, filter. Getting the signal from out the noise is #1 issue in this arena, and probably the main reason for that is just a vast amount of the data that we are handling. When someone is tweeting about Windows, how can you tell easily, is it tweeting about the operating system or is it tweeting just about the, you know, part of the building? There are brands in US called Target, for example. How can we know that they are talking about the Target, the brand itself, and not necessarily about, well, US Targets, whatever. I don't need to follow that thought entirely. Then, of course, is the data mining, which is more or less mainstream these days. People know about the business intelligence, and, you know, they already understand the basic assumptions of how you do the data mining itself. Then the refinement, and I would say the crucial part that's missing, especially in this part when we are talking about the insight, would be interaction. So the interaction is the part which we are missing, and the reason for that is we still don't know how to utilize the data. we have great algorithms. We can today we can gather all the data that I mentioned earlier. NSA is building that huge data center. Probably not the nicest comparison when talking about the big data, but the fact is that even then have solved, and they can solve the problem, which is based just regarding the first elements of this circle, gathering, putting it all together, and performing some preliminary analysis. But what about the interaction? What about allowing the data and exposing the data for the users so they can play with it and get the valuable insights? I think later today, Ratko Mutajic is talking about the open data, so that might be a presentation which could be interesting for you guys. He'll talk, I'm guessing, about the openly available data sets and what you guys could do with that. But then again, we are always faced with the same problem, and it's the interaction and extraction of the real and valuable information. And the key element here is actually perception. Now we are entering this part of the user experience. So what about perception? Perception is something that we create based on our more or less subjective feelings around a service or a product or a general experience that we have. This slide is often used as an example of something called the Gestalt principle. Might have heard of that. So do we see a white triangle here, or do you see a number of rotated Pac-Mans around it? Still, no one has really outlined that white triangle, but you all see it there. It's because of your perception. And the key element which we can utilize our perception, put out our perception to, are visualizations. They are here, and they are very valuable in extending our understanding and gaining and grasping the insights. Again, this presentation will be, I'm guessing, a slideshare, or maybe the organizers will send it to you. So if you don't see something, I apologize because of the light. But again, as I said, visualization are probably the most powerful single thing that could help us understand the big data and interact with it. There's this wonderful work from 2009 from Tamara Mutzner saying that visualization allows people to offload cognition to the perceptual system using carefully designed images as a form of external memory. I will show you several examples of this in the next two slides, so you can get a better understanding of what she's trying to say. But also, the human visual system is a very high bandwidth channel to the brain with a significant amount of processing occurring in parallel at the preconscious level. So even before you start thinking about something, you can already gain the insight of that. And I'm going to do a very, very simple trick or experiment with you guys. I will show you an image, and you don't have to tell me, but I'm guessing that very quickly you'll be able to see what's wrong or what's not in line with that image. So here it comes. Okay, I'm guessing unless you can see the difference in the color, it took you probably a millisecond or so just to understand that you have this. Yeah, I see people saying yes. I have one more, so get ready. What you did here, it's not like you didn't have a for each loop and go, okay, is this one? No, then that one, not that one, not that one. Because you have this huge bandwidth and our perception, you were able in practically a millisecond to understand, okay, there is this red one. So here's another one. Probably even easier because you are not playing with the, we are not playing with the color now, right now. Again, we didn't go and compare each of those elements, like, set them as an array and do some sorting of anything, but we utilized our precognition. It's extremely powerful stuff, and if you think about this, it's amazing. I mean, computer, even I don't know, the pattern recognition software would need some time, and your brain did it just like this. So why is there so much value into visualizations? They're not obviously just nice pictures that I'll show you later on. While do they have the aesthetically pleasing value to it, they're also providing us with a very actionable data, and sometimes very surprising one. They're helping us basically to see something that we are trying to find. And instead of just scrolling through the number of different sheets, just by outlining a different visualization, in a sheer amount of milliseconds, you can get the valuable information. So my first question is, do you know what this map shows? Apart from, obviously, it's in Germany, but quite the difference. Yeah. Okay. So very precisely, that would be the East Germany and West Germany before the fall of Berlin Wall, right? But actually, you are not looking at the administrative division of Germany based on the East and West Germany. You're looking at the ratio of the number of votes that the Linke, the left-wing party in Germany, won at the last election. So you can easily see that in Eastern Germany, they obviously have this very, they have their own strongholds, while in West Germany, it's not so much. But if you take a look, it's a bit difficult to see, but I will try. I will try to show it to you. Do you see it here? It's actually Berlin, and even within the Berlin, you can easily see the division between the East Berlin and West Berlin, and how those, even a thing like that happened. The wall collapsed in the 90s, but the electoral map still shows that difference. The next example I'm going to show is not about Germany, but it's about its neighbor, Poland. Again, looking at something that's basically based on politics. The orange parts are the parts where the left-wing or more liberal parties had the majority, and the blue parts are with the more populist or right-wing parties. But why such a very distinct pattern is presented here? What would be the reason for that? So again, just by looking through the electoral maps, just by counting the number of cast votes, just by trying to understand that, we would not get the full picture. But if you travel back in history and overlay the map of Imperial Germany on the map of Poland while it was occupied, then you can see a very, very close correlation of something like that. And probably the most, I would say, the most profound example, and the one which bears a significant messaging to it, would be the following one that I'm going to show you. How many, again, I'm asking the question, but I just can't resist really. Have you seen this movie? 8 Mile. So you know about the Detroit, and these days, I think they were the first city in the US that actually declared or wanted to declare bankruptcy, and they have the very strong and prominent trend in depopulation. So Detroit obviously is facing a lot of problems. This is the from the U.S. Census Bureau, the number of the inhabitants in Detroit and different counties of it. And what you can see from here is that year by year, the number of people in Detroit are, more people are leaving Detroit than it's actually being born there, and cities drastically depopulating. But what does this have to do with the 8 Mile? 8 Mile is a road in Detroit. And it's a very, very interesting road because unlike Berlin Wall, it doesn't really set any barrier between the two parts of the city. But if you take a look at this image, each dot here represents one person. Blue dots are white people. Green dots are not so white people. So the green dots would be people who are of black ethnicity. There are also orange and red ones, which are Hispanics and Asians. But even in the modern day, they are facing racial segregation. And just by looking at the sole list of how many people live in each part of the city, you wouldn't get a picture of this. So we are actually trying, and we can, thinking of this, we can understand and see that there is an actual socio-culturological problem that is affecting Detroit. Very similar image can be found for Houston. It's basically a star-shaped kind of pattern, not so prominent like this one. If you take a look at the Google, you'll be able to find it. But the thing is, we are using the same data as I showed you here, the same data that has fed this table, and just changing the medium to get the really, really, and for the lack of better words, disturbing message. And just by playing and trying to understand that, I think we could go from big data, just from the regular numbers, to get a big insight. Now if I'm mayor of Detroit, which definitely would be one of the hardest jobs I'm imagining, with this I would have at least a starting point and would know what to do next, or at least I would hope that I know what to do next. So, the issues, as I said again, we are very much fixated on technology. We are still pushing one version of software after another. We are still trying to increase our network speeds. We are still trying to make our algorithms faster, more efficient, more effective. And that's all fine, because definitely that's something we need. Without that, I wouldn't have the data needed to plot that image. But we are missing one key point. We are missing the purpose of the big data. And the fact that most of those information are being related to human lives, to people, in one way or another. So linking the big data and the big insights to the great cause of improving our lives, and not just in a very abstract way, but actually trying to understand which communities have the problems with water supply, which communities are at largest risk for disease outbreaks, is something that's definitely giving us, well, advantage on top of which we can act later on. So it's not about the technology, it's about the actual impact that we have. Technology is, and it should be viewed as a very important and very handy tool for what we do. So the good data, the key steps will be, we need to get from data to insights, as I explained earlier on, and then use that data in the decision-making process. If you're just taking data and aggregating it for the sake of having it, just so we can have it, we are not doing a lot. So I don't want to, I would be terribly dissatisfied and probably very sorry to see that we've invested so much in gaining a big gaining and researching and developing the infrastructure, but not really fulfilling the promise of a technology like this one. I think that all of us who are related to IT in one way or another are doing this job not just for the sake of getting salary or getting paid. We like to create stuff. But there is also one thing that I know that most people really feel very passionate about, is that what you create is actually being either used by real people or helping those real people. So that can be enterprise applications. I don't know, just doing the payment via cell phone, which is extremely useful and very handy. But also we can solve really, really major and big issues. And with big data, but just with the proper focus on what we are trying to do, we have unprecedented opportunity right now. So the 6 core UX principles, when you are going to design a system which is exploiting the big data and trying to get from the big data, as I said, to the big insight, to the actionable stuff which you can use and implement in your decision-making process, would be enhance that insight. As I mentioned earlier, visualizations are a perfect way for something like that. Not each and every visualization. I saw it was basically a joke, but actually a bit disturbing one. People still don't know how and when to use the bar charts and when to use the line charts. So there were, usually I would say, imagine a chart. I don't really have something to write on. Maybe I can improvise. Let me try. All right. Okay, imagine a chart like this, and you have one type of data here, and another type, let's say, you have it here. And let's say that here I have like the M in meters. Sorry for, it's very difficult to write this. And here I can say that these are females and these are males. So this would be a very simple chart trying to show me the very basic understanding that on average males are taller than females. No big deal about that. But even at the universities, when students were presented with this data set and said, okay, decide whether we are going to use the rows or we are going to use the lines, or the bar charts or the line charts, the majority of people actually use the line charts. And what they get was something like this. I'm guessing that I would need to delete this. So what they get look much like this. And that's why I'm saying it's really disturbing. was like this. So again, email, and here the mail. So what do you read from this? It doesn't make much sense. The more mail you get taller. And so that's definitely not something that is an example of a good visualization. But a majority of people actually did that, which is really, really disturbing element of the entire story. That's why I'm saying let's not underestimate the power of visualization. It can provide us with very wrong stuff, or it can provide us with something which we can action upon, which can actually involve our empathy and even position us to better act. Encourage exploration. The idea is that you also put the data in the hands of the users. So you allow them to slice and dice to make sure that they can do whatever they want with it. Sometimes you just won't be able to understand what are you doing. But if you crowdsource it, another buzzword, we should play a drinking game. When he says a buzzword, someone drinks. But when you put the data in the hands of people, they can also come up with some insights which you were not even aware of when you started doing the analysis. Granted, some of that data might be a bit more tricky regarding these issues and everything else, so you might not want to expose everything. But the ongoing trend, even in the legislations of the countries, is that the more data you gain, you expose it and give it to the people in the another trend called the open data, as I mentioned earlier. Coherency and clarity. That we have the unique understanding that the learning curve, when you figure out how to use one piece of the application, is the same as you use it later on, so that you can flatten that learning curve. All these insights are actually, when you think about it, they are very common sense, right? And most of them can be applied to any business or any other web or mobile application. But here we just need to take into account the fact that we are dealing with extremely large data sets. Engaging and compelling, and again, last but not least, offer modern application UX. People are expecting more engaging UX. People are expecting the UX which can provide them that insight I was talking about. And this is how we attack the problem. This is how we basically try to understand and aim from the big data and try to get towards the insight. We have those hardcore technologies, leading edge analytics, consuming the different APIs, as I mentioned earlier. Have you been playing with do you know what's Twitter Firehose?
Yeah.
Who said yes? Yeah, have you tried playing with it?
I've been using a Radeon 6, which is based on Firehose.
Yeah, so the Radeon 6 is one of the, probably the market leader, right?
Probably.
Probably the market leader in the arena of social media analytics and social listening platforms. And they are trying to gain and listen to the data and receive the data from a number of different platforms. One of them is obviously Twitter. Twitter has a limited partnership agreements with a limited number of companies around the world, providing them direct access to the Firehose. Firehose is the collection of all tweets that are being tweeted from the Twitter. And Radeon 6 is basically gathering that data, is drinking from the Firehose, how Twitter likes to say, and trying basically to provide the users with some, as I said, valuable information. During the past year, there were elections in the US. And during the first presidential debate between Obama and Romney, which lasted for about 2 hours or so, the record-breaking thing really happened. 10.3 million tweets have been tweeted in just 2 hours. That's a lot, compared to an average of 500 million per day now. You're talking about the year earlier, and you're talking just about the 2 hours in a day. System which has to address that problem, to listen to all of that, and later on extract the valuable data, is really a system that is under a lot of stress, obviously. And that's why we still, no matter how much I talk about the visualization and how much I talk about the actual usage of it, and how we can change lives and help companies or people do something, we still need that good old hardcore technologies which will help us to gain the results and which will help us to drink from the Firehose or a number of different data providers. But what we miss is actionable, clear, and intuitive manners of presentation. So just by, do you know how the tweets are stored? They are basically JSON. So if you take a look at the tweet, which is literally a JSON, you see a number of different keys and metadata, like when it was created, who created it, what's the URL to the avatar of the person who created it, how many tweets, how many retweets that tweet has had, how many times it's been added to favorites. If it contains a link, Twitter now wraps all the links to t.co wrapper they own, but there you can also see how it looks when it's not so wrapped, or unwrapped obviously. If it includes some open data or open graph data, that will also be in that tweet. So the tweet you see there is a very simplified, user-friendly way of looking at the tweet, which, as I said, in most cases would show the avatar, the real name, the screen name, the Twitter text, and probably the timestamp when it was tweeted or when did you receive it. But you can think about it as an iceberg, where just the tip of it, where just the tip of it is above the surface, while the huge, like 90% of the remaining stuff is buried down. So most users, most people don't really even have the notion that tweets are more than just a piece of text and maybe some image or something like that. But in fact, it's a very complex object, very complex object with a number of different properties and characteristics. And that is one of those issues that I mentioned earlier when we were talking about the problem of diversity or variety of different data that we are getting. So the systems we are building will need to be able to adapt to understand that kind of stuff. Probably, what we are doing, we are storing tweets in NoSQL database like MongoDB, because the structure can change from time to time, so you need to address stuff like that. My main concern here is that I don't want to send message. The technology is not important here. It's the key enabler for the things that we are going to do down the road. But it shouldn't be viewed and considered and used as a, per se, let's just do it for the sake of doing it. So, with that, I would like to conclude and say that algorithms and analytics are great, and but the picture is something that's worth 1,000 words, or probably even more. And I don't think that you need probably more convincing than this one. So, thank you very much for your time. I see that you haven't fallen asleep, at least not all of you. If you have any questions, I'll be ready to answer them now. As I said earlier, presentation will be available on SlideShare. But what I wanted to ask, has any one of you used something called Tableau software? No? Yeah, there are the guys who are trying basically to address those main three issues that I mentioned in the beginning. Either the variety of different data, the speed of it, it's the all-encompassing software tool, which is basically trying to answer that. So I don't have any personal experiences with that. But that's why I was asking and hoping that maybe some of you have tried it to see what you can do with it. All right? Any questions? Yep.
When you're building a new expansion, when you're building, let's say, the data-driven application, and you need to present them, do you use some framework for the visualizations, or are you doing the presentations, from scratch? Some maybe PHP frameworks, or?
Okay, that's a good question. What we are doing, basically, we are our analytics, or basically the underlying analytics of the wall of tweets and the wall of tweets itself now is built on Node.js. So that's the previous presentation was very interesting. So yes, you can actually build a real functioning enterprise-ready application on Node.js, and it won't crash just like that. The thing is that you can actually use a number of pre-existing JavaScript or other visualization libraries. Some of them are really already well prepared for handling large amounts of data. We do two things. If you need to do something that's on a fairly limited scale, And you need to enable people to do, as I mentioned earlier, that exploration part of it, where they can do the slicing and dicing of data themselves interactively. Then you would employ and use the existing kind of JavaScript solution, which you would change or adapt to your needs however you see fit. If you want just to present the data, just a limited set of data, like the one from Detroit was, then you might not really go down that road. Then you might actually use several different tools to get the insight, and then quite literally use the Photoshop or Illustrator or something like that, import the distilled data and produce the infographics or something that's really needed. We still don't have, as I said earlier, we still don't have a one-fits-all solution for something like this. And then again, this is, people tend to agree and say, okay, this is a very new technology, but in fact it's not. It's been around for a while, but now it's entering more into mainstream, and people are getting more and more enthusiastic or aware of something like that. That's why I'm guessing the tool capabilities are still not perfected to the manner that you can just take one JavaScript library and say, here, take those, I don't know, 50 terabytes of data and play with them in real time in your browser. That's still not something that we can do right away. Again, from the background that I know, you guys collect a lot of data from the e-commerce. Obviously, when people do shopping, where they are buying stuff and they are putting it in the carts, and then for example, abandoning that cart. That kind of data still could be considered a big data if you are talking about the large volumes of that data. But what would be the valuable insight for you when talking about UX? You would like to know, for example, well, all you have seen when you go to the Amazon and when you buy a product and they say, people who bought this also bought this one. It's not just based on very simple statistics. Okay, if 10 people buy an iPad, I probably should try and upsell them iPod or an iPhone, right? They're also using a lot of behavioral and cognitive analysis into that one, trying to understand what led you to make that buying decision. So those kinds of things are the things which are informing the overall UX and basically the shaping the form or the shaping the user interface that you're trying to build. So I don't know, are you collecting data somehow and analyzing it already, or? Speaking
specific of our business, yeah, we do e-commerce platforms in Magento, but the fact is that you have all of these types of data that you need to analyze and present it somehow to the client. Mm-hmm. So I was just checking whether you have some suggestion, for.
No, as I said, we don't have one tool. It would all, at least at this point, it would very much depend on what you're trying to do. If you are, there's a number of predefined and market-ready solutions. So if you are tracking, I don't know, the actions of your users on the website, you might go for, there's this tool that's called Crazy Egg. I don't know if some of you have been using it. Yeah, it's a very nice and nifty tool. It enables you to track your users and see where they click, which parts of your website are very important to them, which are not, how deep they scroll. Actually, you have those scroll maps. All of that data is basically already stored on your web server in some sort of logs. Those same logs are the logs which the Google Analytics or Webalizer or anyone else would use. But what they are doing, they are taking it one step further, overlaying it on top of your web page so you can see each and every element where someone has clicked. So instead of just going through an extremely long list of boring data, basically, when you take a look at something like this, it's basically a heat map which you can then again slice and dice. So if you would do that, then instead of building your own solution, something like that would probably be the better. I think it's called D3.js, something like that. Yeah. That's the library that enables a large number of different visualizations. Some of them are already pre-built, so you can just basically feed the JSON or any structured data feed in it. But you can also, I believe, extend it, right? So you could create your own. Well, you use the map as a base and then extend the top of it by adding different methods or something that you need. I'm not sure that we will ever have a one solution that will address this issue. And I don't think even that would be a good idea. So.
Agree.
Thanks for the question. Yeah?
So, the big data big instance. So for example, let's say your company got a call from the mayor of Detroit.
Okay.
And he said,
Hope not.
we have a lot of information, we'll give it all to you. Whatever you need, whatever, we'll just give it all. So how do you go about, how do you start, you know, thinking about, okay, which direction can I take, what can be useful?
Okay.
So how do you do that? Or do you just get, look, I want the census information, or I want this kind of information? Here you go.
Again, it depends. But to try to be, you know, more to the point of your question. First of all, I probably wouldn't ask them for all the data. I will already have some idea of, you know, the general understanding of the problem that I'm trying to solve. Would it be poverty, or would it be a disease outbreak, or, you know, I would have a certain scenario in mind. And even from that, as I said, the table data, as they call it, in that raw and unstructured, or structured but still raw way, is actually not that bad. It can still allow you for a lot of filtering, and you can get and see, okay, for information on population you would need it, ethnicity, you would need the geographical location of that person, you would probably need what would be useful, median income, for example, like that. So you can draw parallels. Is there any correlation between the people of certain ethnicity and their earnings? It's a lot of guesswork, to be quite honest. And because you're trying to solve a problem that probably no one has solved before you, and trial and error, I believe, should be even encouraged at this point, because otherwise you are limiting yourself. I mean, it's good, as I said, just to say, we don't need, I don't know, precipitation, the amount of rain for the certain county. But you obviously know that, you know, some of that data is already in your minds more relevant than the other. I would start from that. I would have a set of limited elements, and then probably experiment and try to add more and see if they are actually adding more to the signal, or they are just adding more noise. But it's a very, very difficult stuff. People often say, and I like that comparison, it's in the cross-section of science and art, where you need to think really interdisciplinary, right? So you don't really just rely on one source, on one method. I showed just several visualizations here. There are literally hundreds of them. And not all of them are, as you've seen with the bar versus line chart, not all of them are communicating the right value at the right time. So there would be a lot of experimenting with that, which would be exciting, obviously. Thanks for the question. Any others? All right. I think we are a little bit, 10 minutes before 3. Thank you so much for your time. If you have any questions, catch me around. I'll be here tomorrow. I am ViberC at Twitter. My email address is also here, so feel free to ask me if you have any questions. Thank you so much for coming.